Alright, so what we're going to do now is we're going to take a look at our very first example. And what we want to do is we want to find the focus, right? That's a point of the parabola given by this equation. And that's all the information that we've been given. So just keep in mind that if we were to graph this parabola, let's say maybe on Desmos or on your graphing calculator, you would just see the curve of the parabola. You would never see the focus, and you would never see the directrix. But here we're being asked to find that point that does exist, which is the focus. Alright, so the first thing that I want you to know in this equation is that the x value is squared, not the y. Okay, so because the x value is squared, what we're going to do is we're going to make this look like the first version of the standard form equation of a parabola. So let me write that down for us. It's x minus h squared equals 4p, and then we have y minus k. It's important to know this because at this point, knowing that the x value is the one that is squared, it gives you some idea about the direction of the parabola. We know because of that information that it either opens up or it opens down, but it doesn't open left or right. Okay, so we're working towards something that's going to look like this. All right, so the first thing that I want to do in this equation, and I'm just going to write it down real quick so we can start our work. I want to avoid all these fractions, so I'm just going to clear the fractions by multiplying by an LCD, right, a common denominator, which is 2 in this case. So I'm going to multiply everything by 2. You don't have to, this is just preference, right? If you don't mind working with fractions, then you can just keep the fractions. So this is going to give us 2y equals 2 times 1/2 is 1, so just x squared. 2 times negative x is negative 2x, and 2 times 1/2 is 1. Okay? Now, what would be awesome is if this was a perfect square trinomial, so that we could factor it, alright? But unfortunately, this positive 1 is kind of messing up everything. The factors of positive 1 are either 1 times 1, or negative 1 times negative 1. Actually, I think I made a mistake. I did make a mistake. Give me 1 second. This should be negative. So what that means then is that this was negative, and this would have been negative. So let's backtrack a little bit. What I should have done is multiply this by a negative 2, and the reason that we would want to do that is so that this becomes positive. I'm sorry about that, so let me just make that change. When I distribute that negative 2, I'm going to get a negative 2y, a positive x squared, a positive 2x, and then a negative 1. This is why we use pencil. Alright, so let me just rewrite that. Negative 2y equals x squared plus 2x minus 1. Some things have definitely not changed. Made mistakes when we were in class together, still making mistakes. Alright, this is actually the second video of this that I'm making, so definitely not a stranger to making mistakes. Alright, so as I was saying before, this would be perfect if this were a perfect square trinomial. This one previously was, but that's because I had the wrong sign on the x. But now we can see that this is actually not a perfect square trinomial because the only factors of negative 1 are positive 1 and negative 1. And those two numbers are never going to add or subtract to a positive 2. So what we're going to do is we're going to move that negative 1 over to the other side. So I'm going to do plus 1. So now I have negative 2y plus 1 equals x squared plus 2x. Okay, so now what I want to do, remember, I want this, my x, to be a binomial squared. Alright, and that constant right here is going to be the first coordinate, the x coordinate of my vertex. Okay, so let's think about this. Remember from yesterday when we were completing this square, we were using b divided by 2 and then squaring it. Alright, so the b in this case is positive 2. So 2 divided by 2 is 1, and 1 squared is 1. So I'm going to add 1 to this side, and that's going to give me a perfect square trinomial. But don't forget that you also have to do it to the other side. Okay? That part is really, really important. If you forget it, it throws off all your numbers. So now on the left side, we have negative 2y plus 2. And on the right side, I'm going to go right ahead and just factor that. All right, I'm going to have two binomials that are x plus 1. Right, that's just factoring. Okay, so you can distribute that if you wanted to, and you would get that exactly. All right, so the only thing I'm going to do now is remember that I want it to look something like this, and my x values are looking pretty similar, but this part doesn't really match. Right, I should have some kind of parentheses because I want a 4p on the outside, which won't always show a 4, but I'll show you in just a minute what that looks like. So I'm going to actually factor out a negative 2, and I'm going to end up with y minus 1 equals x plus 1 squared. So if you want it to look identical to this, you can just switch the two sides, right? So I'm going to have x plus 1 squared equals negative 2 and y minus 1. Alright, so the reason that this is really helpful is because now we can identify the vertex, but also the focus. Alright, and remember that that's what the question is asking. Alright, let me just, right, we're being asked to find the focus. Okay, so let's talk about what we have so far. Remember that the HK on a circle, that was a center. On a parabola, that's now the vertex. Okay, so HK, I'm just going to jot that down, which is the vertex. In this case, remember we take the opposite signs. H is always with x, and K is always with y. Okay, so the vertex here is negative 1, positive 1. Okay, this right here is basically 4p, right? So the p is basically the distance from the focus to the vertex. Alright, so it's the distance. Okay, now we have to be careful here because p is hidden inside of this value. So I need to be able to write negative 2 as 4 times something. Why 4? Because that's what we have here for the equation. If you're interested actually in seeing the proof for it, it is in your textbook. It says there, it's on page 707 in your textbook. If you're interested in figuring out why it works that way, why that 4 is even there, I take a look at that. So 4 times some number has to equal negative 2, and that number is negative 1/2. Right? If you're not sure how I got that, you can very quickly just do negative 2 divided by 4, simplify it, and you have negative 1/2. So P, the distance from the focus to the vertex, is negative 1/2. Alright, so we're almost where we want to be. We want to find the focus. We want to find the point that is the focus. So let me give you a little bit of a drawing here. Okay, so the vertex is at negative 1, positive 1. Alright, now this parabola is either going to open up or down, and hopefully you see a negative and think down. Okay, and that would be correct. Alright, so I'm just going to pretend that this parabola opens this wide. Okay, I just kind of made that up. But now what I have is P. P is negative 1/2. That means that from the vertex, if I go down 1/2, well, that is the focus. So the question is asking us, well, what's the coordinate of that point? Alright, so the focus definitely has to align with this point, right? It's only 1/2 down from the vertex. So the x value is still negative 1, right? But this is a half unit away from this vertex. So I'm going to go half away from this and a half down towards 0. So I have 1/2. So the coordinate of my focus for this parabola is negative 1, 1/2.